here we go. Right triangle, once more. This time the angle is missing. We do not know what this angle is worth. Okay, but we do have two sides, right? This one here, 29, it's a leg of the triangle. And this one here, 35, it's another leg of the triangle. Neither of these are the hypotenuse. From this orange angle, this is going to be the opposite side. And from this orange angle, this is the adjacent side. Neither of them, like I mentioned earlier, are the hypotenuse. I think I spelled that right because it's across from the right angle. So I'm going to set up a trig ratio in order to figure this out. So the structure of a lot of these problems always end up kind of being the same because we're going to use SOHCAHTOA to determine what ratio we can use to write an equation. And we write that equation and solve for the unknown. So here, from this orange angle, opposite, adjacent, I can label those, right? Opposite and adjacent. Opposite and adjacent is this guy. That means I'm going to use my tangent ratio. So I'm going to set up my equation with this structure. The tangent of the angle equals the opposite over the adjacent. So it's going to look like this. And I put kind of unknowns for all three of these things, the angle and the two sides. This is a question mark, so I'm just going to keep it as a theta. It's an unknown. That's the unknown we use in math typically for angles. Now these two are going to be numbers because I can see them on the picture, right, on the triangle. Opposite side is 29, and the adjacent side is 35. So to solve for theta, I need to get it out of the tangent function. It's currently being taken the tangent of it, so I need to undo that. So I'm going to write just kind of below it so we can kind of very clearly see what's going on both sides. I'm going to move this guy over so I got a little bit of room. What we're technically doing is taking the inverse tangent of both sides of the function. We are undoing the math. The inverse tangent of the tangent, which sounds weird, cancels out. That's what we want it to do. We want the tangent part to go away so that theta is on its own and it's set equal to the inverse tangent of this ratio. And this part can just go into the calculator. You're going to type it as you see it. The inverse tangent, it's a secondary feature. So here, I'll close it out so we can see all of this. Second inverse tangent, so it should say tangent to the -1. And then I just do 29 divided by 35, close my parentheses, hit enter. And let's see, I'm going to get 39.6. That is my angle measure. 39.6. And that is reasonable for this drawing. Even if I'm not worried about scale, I know it's an acute angle in a right triangle. So having an answer being 39.6 definitely fits with what I would expect, something between 0 and 90. Okay, hope that's helpful. Message me anytime with questions.